This next video, we move on to our next shortcut rule for differentiation, which is referred to as the product rule. As the name would suggest, it is used for the situation where you have some function that is made up of two or three other functions that are multiplied together to create that function. Now, here it is in some mathematical notation. So if f of x, when we're doing this, we'll call this the first factor going here. So this is the first, and then we'll refer to this one, g of x, as our second factor. And the product rule says that if you have two things multiplied together, the derivative turns out to be the derivative of the first one multiplied by the second one, just as it is, plus the first function, just as it is in the original question, multiplied by the derivative of the second one. I say, well, how did you know that? That's what these little symbols mean, g prime and f prime. So this is derivative of the first multiplied by the second plus the first multiplied by the derivative of the second. So when you're doing these differentiation rules, as we kind of move into these next three, I really suggest you get in the habit of saying the rule as you're doing it. So I've kind of got it down here in words. So the derivative of a product of two functions is so starting here, as you're doing your derivatives, say this: derivative of the first multiplied by the second plus the first multiplied by the derivative of the second. If I, as I said here, get in the habit of differentiating and verbalizing when you get into these multi-stepped derivatives. So if I look at this first example, this would clearly be an example of a function multiplied by another function. So yes, we could expand it all out and have a bunch of power rules and use the power rule. However, that would fall on its face if I put an exponent up there, or if I make these have multiple factors or make them have more terms. So avoid going back and say, oh, I'm really good at power rule, I'm just going to do everything with power rule. That's not going to work in many, many situations you're going to be encountered with. So this will be my first factor, and this will be my second factor. So what I'm going to do is use the the product rule. And the product rule says, I'll try and color code this for you. Derivative of the first. Treat this first bracket like a question on its own, like we did in our last video of power rules. So just do the derivative of this, which would be 21 x squared minus 2x. A constant has a derivative of 0. There's the derivative of the first factor. Well, the rule says derivative of the first multiplied by the second. Well, that means just leave it like it is. Don't do a thing to it. Just rewrite it. There's derivative of the first multiplied by the second plus the first. Just rewrite this one. 7x cubed minus x squared plus 5. There's your first. Now multiply that by the derivative of the second, which would be 9x to the 8th plus 3x minus 5. No, sorry, ahead of myself here. I'm going to do the derivative. So 9x to the 8th plus 3. Right, 3x, the derivative would be 3, and I've got constant, it would be 0. So when you look at this, I really only did any work per se when I did derivative of the first and the derivative of the second over here. The other parts of the function of the derivative, I was just rewriting the original question. So if I show you the mathematical version of it, so this would be like your first. So instead of first, let's call it f of x. Let's not call it f of x because I already have that. Let's call it g of x. So this one we'll say is g of x, and this one will be h of x. Well, the rule said f prime of x would be derivative of the first. So if the first is g of x, that's the symbol for the derivative of the first, multiplied by the second, which is just the regular h of x, that's the second, plus the first, which is g of x, multiplied by the derivative of the second, which was h prime of x. So that's, if I go back here and look, that's what they mean by this. And as I said, these two here are the only two where you're really using your differentiation rule, which of course is relying upon us have been exposed to the power rule in our previous section. Okay, let's have a look at these next couple. All right, so the variable doesn't matter. It just means that in this case, the variable is t rather than an x. You do it the same way. H prime of t would be, so the rule is derivative of the first, 3t squared minus 5. Right, that's the derivative of the first bracket, multiplied by the second. Plus the first multiply that by the derivative of the second. Now 6 radical t is the same thing as 6t to the half. So when I do my, it's a 2, 1/2. So I have to multiply a half by 6. So I'm going to get 3t, take 1 off of the exponent. That's going to go to negative a half. And then negative t to the negative 5 will become plus 5t to the negative 6. Derivative of the first multiplied by the second plus the first multiplied by derivative of the second. So again, I'll just highlight for you these ones. Derivative of the first, yes, I had to use some calculus. Multiplied by the second, I just rewrote that second factor. Plus the first, again, I did nothing other than rewrite the original first factor, and then here I had to do some power rules to differentiate the second factor. Okay, that's how the power rule, the product rule works. If you look at the next example I have, well, the difference being now is that there are 3 factors. Well, if you have 3 factors, the product rule just continues. It's derivative of the first, but instead of multiplied by the second, it'll be multiplied by the second and the third. And then it'll be plus the second multiplied by, the derivative of the second multiplied by the first and the third, and then plus the derivative of the third multiplied by the first and the second. Okay, so easier if I just do that as I'm going. So because there's 1, 2, 3 factors, my derivative will now be derivative of the first multiplied by the other 2. I'll color code this one again. So your other 2 are just 4x squared, take away 2x plus 3, 9 minus x to the 6. So derivative of the first factor, this is a factor, this bracket, multiplied by the other 2, plus derivative of the second. So look at this bracket only. The derivative in that bracket would be 8x minus 2. Derivative of the constant is 0. There's derivative of the second. Multiply that by the other 2. So the first one, 7x cubed minus 5. And the third one, 9, subtract x to the 6th. I'm running out of room, so I'm going to go down here. And I'll put plus. And now I differentiate this one, which would just be negative 6x fifth. And then I multiply it by the other 2 factors. So the other 2 factors are 7x cubed, take away 5, and 4x squared minus 2x plus 3. So what I'll tell students at this point is, yeah, these things do become space consuming. They take up a lot of space in your notebook, but there's really not a lot of work per se. Here I did derivative of this bracket and I just rewrote the other 2 factors. Plus I took the derivative of the second bracket, I just rewrote it multiplied by the other factors. Plus derivative of the third, and then I just rewrote it multiplied by those other ones. So only the 3 highlighted things or factors are where I had to do differentiation per se. All right, one more. This is another one that has 3 factors, but this would work if you had 3 factors or you had 33 factors. You would do it the same way. Derivative of the first times all the rest. Derivative of the second times all the rest. and so on and so on. That pattern would continue. Just give it some more room here. All right. Triple product, three factors multiplied together. Derivative of the first, 12x to the 11th minus 15x squared. I'll color code again. Multiply that by the other two. 7x cubed plus x minus 5, 4 radical x plus 2. There's derivative of the first multiplied by the second and the third. Plus derivative of the second, which would be 21x squared plus 1. Multiply that by your other two factors. So your first, x to the 12 minus 5x cubed, and your third one, 4 radical x plus 2. Now when you get into these triple products, you often run out of room. Even on your notebook page, that may happen. Just put your little arrow. So now plus derivative of the third, which now 4 root x is 4x to the half. So 1 half times 4, 2. Subtract 1 from your exponent. The derivative of the constant is 0. There's the derivative of your third one. Multiply that by your first two. And there you have it. That is the product rule. So it is used when you've got a function comprised of factors that are multiplied together to make up that function. So I started out where I had just two factors, which is what our rule was developed upon. And then I evolved to where I had three factors multiplied together. Okay, so that is referred to as the product rule.